Given question, the coefficient of friction between the floor and ladder is 0.4 and between the wall and ladder is 0.25. Determine the least value of theta for which ladder may be placed without slipping.
In this question, we have to find out angle theta for the system in equilibrium. Ladder is having point of contact B with vertical fixed surface and point of contact A with horizontal fixed surface. We are going to solve this question by virtual work method. So we will consider this ladder will slip by a small displacement. So I will show here the position of the ladder when it is slipped with small displacement. So this point B will move in the downward direction and here will be new position B dash. So I will show here the new position of the ladder with the help of red marker. And at contact point A, this is the new position of this ladder is A dash. Now in virtual work method, we use force multiplied by displacement. Now if we observe, here is the frictional force that will act at point A as well as at point B. Ladder is in contact with horizontal fixed surface. So we have to show normal reaction. So normal reaction, that means we have to draw perpendicular line to the fixed surface. So I will show here vertical line and normal reaction at point A is NA. Now in the same way at point B we have to show normal reaction. So surface is vertical. So we have to draw perpendicular line, that is the horizontal line, and normal reaction at point B is NB. Now this point A is displaced from A to A dash, that is towards the right hand side. So we have to show frictional force is in the opposite direction. So I will show here the frictional force in the opposite direction of displacement, that is towards the left hand side. So frictional force, that is mu into NA. So I will show here F is equal to mu into NA. So this mu, that is this coefficient of friction in between this ladder and the horizontal surface is given. F is equal to 0.4 NA. Now in the same way we have to show here the frictional force. So this B to B dash displacement is in the downward direction. So we have to show frictional force, that is in the upward direction. So F is equal to mu into NB. So mu is given 0.25 into NB. When we apply virtual work method, then we have to take force multiplied by displacement. Now if we observe this point A, then it is displaced from A to A dash and force applied F is equal to 0.4 NA. So how to find out this displacement A to A dash? So I will show this displacement is along the horizontal line. So we will show the small displacement as a delta XA. And we have to find out. So this is the delta XA. Now next point is point G, where force 300 Newton is acting. And at this point G, the displacement is from G to G dash. Now this displacement is along the vertical line. So this displacement is delta YG. So for this vertical displacement we will use Y. Then next is point C, where the force 800 Newton acts. And here new position is from C to C dash. So this displacement is along the vertical line. So we can say that the displacement is delta YC. And next point is point B, where frictional force F is equal to 0.25 NB acts. And the displacement is from B to B dash and it is delta YB. So we have to find out all these small displacement. Now we will first find out the position of this point A. For that we will consider this vertical line as a y-axis. So I will continue this line This is known as y-axis. And this horizontal line as a x-axis. Then this point O as a origin. Now we have to find out O to A. So how to find out O to A? So I will say that it is XA which is equal to O to A and which is equal to. Now we will concentrate on triangle BOA. So in BOA, if we take sine of theta, then OA divided by BA. So BA or AB is equal to 6 meter is given. So I will write here sine theta is equal to OA divided by AB. So AB is 6. So we can say that OA is equal to 6 sine theta. So I will write here 6 sine of theta. Now in the same way we will find out this vertical displacement. That is, we have to first find out the position of this point G. So from this point G I will draw one vertical line, and here this point of intersection I will say this point is P. Now we will concentrate on triangle PGA. Now if we observe, this is the same inclined line, and with vertical line, these two vertical lines are parallel to each other. So here is the same angle theta. So we have to find out this distance P to G. So how to find out? So if I write cos theta is equal to, then it is PG divided by A to G. Now AG is given 3 meter. Distance A to G is given 3 meter. So we can say that PG is equal to. So I will write P to G. That is nothing but location of G. Vertical location of G. That is, I will say YG is equal to PG. That means YG is equal to AG. That is 3 cos theta. Now in the same way we will find out vertical position of the point C. So again here is the point of intersection is Q. So here the inclination is theta. So we have to find out C to Q. So again cos of theta is equal to CQ divided by A to C. Now AC is also given 5 meters. So CQ, that means YC is equal to CQ is equal to 5 cos theta. And now position of this point B. So again in the triangle BOA. So here position of B to O to B distance, how to find out? That is, suppose if I take cos theta is equal to OB divided by AB. So AB is given 6 meter. So YB is equal to OB, and which is equal to 6 cos theta. So these are the position of the different points where the different forces acts. Now we have to find out delta XA, delta YG, delta YC, delta YB. So we will differentiate all these positions with respect to theta. So how to differentiate? So I will get delta XA. So delta XA is equal to 6 sin theta. That means 6 cos of theta delta theta. 6 cos theta delta theta. Then delta YG. Delta YG is equal to. Now cos theta, that means minus sin theta. So minus 3 sin theta delta theta. Then delta YC. So it is equal to minus 5 sin theta delta theta. And then delta YB. Minus 6 sin of theta delta theta. So these are the displacement at various points. We will apply principle of virtual work method. So for that, sign convention is important. For horizontal forces, the forces or the displacement towards right hand side, we will use positive sign, and the forces and displacement the direction towards left hand side we will use negative sign. In the same way, for vertical forces or displacement, the direction in upward we will use positive sign, and for the direction in downward we will use negative sign. Now we will first consider the point A. So at point A, force is towards left hand side. So we will use negative sign for this force 0.4 Na. So minus 0.4 Na multiplied by displacement delta XA. So this delta XA direction is towards right hand side. So for right hand side direction we will use positive sign. So here 6 cos theta delta theta. Now next we will take this point G. So direction is downward direction. So we will take minus 300, and displacement is also in downward direction. So that this displacement delta Yg we have to consider with negative sign. So here minus 3 sin theta delta theta. Next is 800. So it is downward direction. So minus 800 multiplied by the displacement we have to take with minus sign, minus 5 sin theta delta theta. Next is this force 0.25 Nb. It is in upward direction. So for the upward direction plus 0.25 Nb multiplied by displacement. So this displacement is in the downward direction. So we have to take with negative sign, minus sin theta delta theta, and all this summation is equal to 0. Now we will simplify this. So we will take the delta theta as a common term and we will transfer to the right hand side. So it will become 0. So remaining term minus 2.4 cos theta Na. Then this minus minus will become plus 900 sin theta plus this minus minus will become plus 8 multiplied by 5, that is 4000 sin theta minus 1.5 sin theta is equal to 0. So this is the simplified form. So we have to take this simplified form of the equation by the principle of virtual work method. Now in this term Na is unknown term. Now in the same way there is also Nb term, this is also unknown term. So we have to find out the value of Na as well as Nb. So how to find out? Now we will consider if the system is in equilibrium. Then we can apply the rule summation of all horizontal forces is equal to 0 and summation of all vertical forces is equal to 0. Now we will consider the system in equilibrium, then summation of Fx is equal to 0. Now if we observe horizontal forces, now in this diagram horizontal forces is this frictional force, that is 0.4 Na, and here Nb. These two are the horizontal forces and these two are opposite in direction. So we can write 0.4 Na is equal to Nb. So we can use this relation in between Na and Nb. Now we will consider summation of all vertical forces is equal to 0. So here we will use with direction. So we can say that this Na plus Na minus 300 minus 800 plus 0.25 Nb is equal to 0. Now we can use the relation in between Na and Nb. So we will use Nb is equal to 0.4 Na. So this 0.4 multiplied by 0.25. So that is equal to 0.1. So 0.1 Na and this Na. So here is the plus sign. So 1 plus 0.1, that is 1.1 Na is equal to. Now this term, negative term, we will transfer to the right hand side. So it will become 1100. So Na is equal to 1000 Newton. So we will get the value of Na. So how to find out Nb? So Nb is equal to 0.4 multiplied by 1000, that is equal to 400. We will put the values of Na and Nb in this equation. So here Na is 1000 minus 2.4 multiplied by 1000 into cos of theta plus 900 sin theta plus 4000 sin theta minus 1.5 into 400 sin of theta is equal to 0. Now we will simplify this. We will take cos theta term on one side and sin theta term to the other side. So when we simplify this, then we will get the relation in, that is equation in between cos theta and sin theta. So sin theta by cos theta, that is equal to tan theta. Now if we solve this, we will get 4300. So we will transfer it to the left hand side. So it is equal to 0.558 and therefore theta is equal to 29 degree.